Okay, so now let us come to the next exercise. This is about the properties of subtraction of rational numbers. So, the subtraction of rational numbers also satisfies the closure property. That means if you subtract two rational numbers, you should be getting a rational number. It does not satisfy it. So, subtraction is, it satisfies the closure property. It is not commutative. A minus B is not equal to B minus A, isn't it? So your subtraction is not commutative and subtraction is not associative also. It is not commutative and it is not associative. Okay, that means A minus B is not equal to B minus A. And not associative means your A minus B minus C will not be equal to A minus. Doesn't mean that you can do anything. Okay, cannot do it like this. So these are not true. Okay, it's not associative, it is not commutative. Okay, now let us move ahead and see what are the type of questions over here. In next, some of them I have done. I don't want to make my videos too long. Just a few, nothing. These things you already know. Subtract this from this. Okay, this from this from this. So if I have to subtract this from this, what am I going to do? Subtract minus 3 1 by 5 from minus 4 7 by 9. So this is from, so this should come first. I have to subtract from this. So this should come first. And whatever I do, I have to subtract. That means minus of minus 3 1 by 5. So be careful, okay? So subtract this from this. So first this has to come because I have to subtract from this. So this has to come first and then minus of whatever I have to subtract. So this minus and minus becomes plus. Okay, then the normal thing, minus 43 by 9. Okay, plus this is 5, this is 15, 16, plus 16 by 5. Your normal, you take the LCM 45 and this comes out to be equal to minus 126 by 45. The next thing which we have is this question. This is question number 4 again. What rational number should be subtracted from minus 4 by 3 by 5 to get minus 3.5? Okay, what number should be subtracted? So let that number be x. Let x be that number. So it has to be so that number has to be subtracted from this. Okay, so minus 4 3 by 5 minus x should give me minus 3.5. That is what this sentence says. What rational number should be subtracted from this? So I have taken that number as x. So minus 4 from this. So from minus 4 by 3 minus x is equal to minus 3.5. And then you just solve it. Okay, so keep minus x on this side. Take this on this side. This becomes plus. So here we have minus x is equal to minus 3.5 plus 4 3 by 5. So minus 7 by 2 plus 23 by 5, all that you do. So we get the value of minus x as 11 by 10. Okay, this side was minus x. So x is equal to minus 11 by 10, which is minus 1 by 10. By class 8, you must be knowing these addition subtractions. Okay, nothing for me to explain. Now look at this one. It says, which of the following is true or false? Okay, this minus this is not a rational number. Is it a rational number or not? It is a rational number. So this statement is false because closure property is satisfied. Subtraction of two rational numbers should give you a rational number. Minus 5 by 7 is the additive inverse of plus 5 by 7. It is, isn't it? If I add these two, I should be getting 0. So this statement is true. This statement is false. It is a rational number. They are saying it is not a rational number. So their statement is false. This additive inverse is true. Third one, 0 is the additive inverse of its own. Yes, if you add 0 plus 0, you are going to get 0. So 0 is its own additive inverse. Commutative property holds for subtraction of rational numbers. Just now we had discussed no. Okay, commutative does not hold, associative does not hold. So here it is saying commutative property holds. So this is false. Associative property does not hold. So this is true. Okay, because even this does not hold, this does not hold. Here it is saying associative property does not hold. So this statement is true. Now 0 is the identity element for subtraction of the rational numbers. Is it true or is it false? It is actually false. Okay, I think when I was doing additive identity, what I told you is that a plus 0, if you're getting is it as a. I think that I missed out on something. A plus 0 is equal to a is equal to 0 plus a. That is why we say that 0 is the additive identity, not just this. Okay, a plus 0 is equal to a is equal to 0 plus a. Then we can say that 0 is the additive identity. Is that true for subtraction? A minus 0 is equal to a, all right, but is it equal to 0 minus a? Not, isn't it? So for subtraction, it is not the identity. 0 is the identity element for subtraction of rational numbers. No, this statement is false.